minus 1, it's not equal.
No, because it's plus. So if it was x squared minus 1, you'd be right. But since it's x squared plus 1, you can't factor that.
Darn.
So when you can't factor to simplify, then you just have to deal. So in this case, we don't have holes. We have a vertical asymptote at x equals 1. But we don't have a horizontal asymptote. And that's because the degree of the numerator is greater than the degree of the denominator. So when we don't have a horizontal asymptote, we may have a slant asymptote, also known as an oblique asymptote.
Ooh, obliques.
Okay, oblique or slant asymptote. Oblique in general, like, kind of just means like slanted. So, all right, to find it, we have to do long division. But don't like say, because it's not even like all of long division. It's kind of like mini long division, because you don't really have to finish it. So what you do is you take the numerator.
I hear this song way too much.
I'm going to add a 0x, and we are going to divide the denominator. So I'm adding that middle term, but you don't really have to do that. You could probably get away with not doing it if you forget. It'll just be like uncomfortable.
I'm so used to using the square root
Yeah.
sign that I'm like, oh no.
Oh no,
That's what I
that's
was
like
about
the
to say.
divider guy.
I
Call me
know, but
divider
I
guy.
messed up.
Yeah.
You know
So
you're
basically,
old.
I'm
You
the
know
right
you're
guy.
old.
Alright, so to do long division, we have to ask ourselves, what do we multiply x by to get x squared? X. And so that's what we put here, and that's why I like to add that middle term so I have somewhere to put it. And then what we do is we multiply.
Wait, how come the horizontal is nothing?
So horizontal asymptotes will occur if the denominator has a greater degree, or if they have the same degree. But this one, the degree of the numerator is greater.
Oh, because it's got
Squared.
Squared.
Yeah, so that's why we don't have horizontal, we have a slant. So if the numerator is greater, we have a slant instead of a horizontal.
So basically a diagonal.
Yeah,
Okay. How cool is that I got that?
so we're gonna multiply x times x, that gives us x squared, which is good. And then x times negative 1, which is negative 1x. And then after you do that, you're supposed to subtract everything. So what I do is I just go,
You're just gonna.
meh, meh.
Yeah.
So that cancels these guys, and I get 1x plus 1. And then you have to repeat the process.
I don't like this one.
What do you multiply x by to get 1x?
1.
1. So you're going to put plus 1. And then we multiply. 1 times x.
1x.
1 times negative 1. Now, the only reason I'm doing this part is just to go through the process, but eventually we can skip this part. So the next thing we would do is subtract. Yeah, and we get a remainder of 2. Now, the remainder doesn't matter. We don't need the remainder. The remainder is irrelevant to the asymptote. So in theory, we could skip all of this part, but I just want to show you that if you get a remainder of 2, then that means it's good.
Okay.
If you get a remainder of 0, then that means you could have canceled something, because that means it would have gone in. So if you get a remainder of 0, that means you could have factored and canceled that factor. Now, if you're like confident that you like didn't need to do that, then good. You can just skip all of this. Once you put this number up here, you're done, because the remainder doesn't matter. Whatever you get up here, that is part of your equation of your slant asymptote. So your slant asymptote is going to be at y equals x plus 1. And I'm going to show you like quickly what that's going to look like over here.
Why don't we just call it a diagonal asymptote?
I don't know, I didn't name it.
I mean, it makes sense though, right?
Yeah. So it just says to find all the asymptotes, but I want you to know what it looks like if it's graphed too, just so you have an idea. So the vertical asymptote of this one is going to be x equals 1. Okay. Now the slant asymptote is y equals x plus 1. So you have to know how to graph a line to graph that asymptote. This is the y-intercept of the asymptote. So that's right here. Okay, you follow me?
Gosh, no.
And then it has a slope of 1 Okay, slope of 1. So you go up 1 over 1. Okay, and that's your asymptote. That's your slant asymptote.
It's disgusting looking.
I know, sorry.
Looks awesome. You kidding me?
Awesome.
So let's just graph a few more points just so we have like a graph over here. So just so we're not confused.
I need to,
It's
like-
not that one. Let us plug in a 0 for x. That gives us -1 for y. So that's our y-intercept. So you see how that point is in this little like sliver here? So that means that the rest of our curve is gonna kind of like curve in here. It's gonna look kind of like if someone like smushed a parabola, but like and then like turned it like blah.
Okay.
They
Yeah.
distorted the parabola.
Yeah.
They turned
So
it into
I
an
want to plug
exorcist.
something else in this area. So maybe like -1, because -1's right here. So maybe that'll put a point over here.
So the slant is literally just slope. You just go like 1 over 1.
Yeah. So I started with the y-intercept and then slope,
So y-intercept of 1.
and then slope of 1.
Over.
So I put in -1 here.
Why do
I get 1 plus 1 over -2. That's 2 over -2, which gives me -1 again.
What?
Which
Pretty cool.
means that in between those points, it's probably like coming up a little bit like this.
Wait a sec. That's weird though.
I don't like this at all.
I think it's awesome.
No.
If you graph it on your calculator, you'll like it. You might like the way it looks better.
It's like doing this. It's like literally doing this.
Somebody do it on the.
You know why
calculator.
you know why it's like
I
doing
like
that?
that.
Because technically you're not touching the paper. The molecules between your hands and the paper are touching.
Interesting. All right, and then
yeah.
I need to know what's happening in this little. It's either in this sliver or in this sliver, and the only way to know is if I plug in a value greater than the vertical asymptote. So I need to plug in like a 2 and a 3
Oh, very cool.
to the right of that
That was very
asymptote. So let's plug in 2.
Let's see this too.
So this is 4 plus 1 is 5 over 1. So 5. So 2 comma 5. So he's up there in that little sliver.
Make sure he's in that sliver.
And then we'll do
Thanks,
3.
Brandon.
You're welcome. Anything.
So that's 10 over 2, which is 5. Oh, look, it's like the same sitch. So again, it's probably doing like this.
Probably, but we haven't gotten anything.
It
Yeah.
is, it's doing that.
We haven't gotten anything but
You
those
could plug
things.
in like 2.5 to see where that point is, but you know.
So is this technically exponential or what the heck?
No, this is a rational function.
These are so ugly. Like this just
Yeah.
makes me very uncomfortable.
That's ugly. I think he's cute.
They're a little goofy, but
He's got character.
You have weird taste.
Sorry.
Weird taste in graphs.
All right.
I like lines.
Questions?
that don't curve.
I have a lot of them.
I won't make you graph all of these. Like, what I want you to do is practice finding the asymptotes. So for vertical asymptote, you set the denominator equal to 0 and you solve.
Oh, I need to like write down one more equation real quick.
-2.
Right.
Yeah.
So x equals -2 would be our vertical asymptote.
And that's just the bottom part, right? That you just like set it equal to 0. Is it always like that?
For vertical, yeah, that's like the rule.
I just forgot the rule.
So horizontal asymptote, you're
Yeah.
looking to see if it's either bottom heavy or if the degrees are evened.
Top heavy.
It's
It's
top
not bottom heavy and it's not even, so that means there's no horizontal asymptote. If it's top heavy, which it is, then that means there's a slant asymptote.
Disgusting.
Okay, and remember, you would have wanted to try to factor and cancel first.
Can you get a horizontal and a slant?
No. Good question. It's either one or the other. Okay, so we are going to divide x squared minus 2x plus 5 by x plus 2.
And this one we don't have to add a 0 because it's already like there's already an x.
Yeah, right. Okay, what do we multiply x by to get x squared?
Okay.
So So I'm gonna put that here. And then I'm gonna multiply
Why didn't I just cancel?
times x is
Oh, wait,
x
never mind.
squared.
Ms. Rupp, did you grade the test yet?
I'm working on it.
Oh, okay. I'm just checking.
How
I
badly
haven't
did
checked
everyone
yet.
fail? I know I did so bad on it.
It was a tough
And
test.
then we will subtract minus minus. So x squared minus x squared is 0. Negative 2 minus 2 is going to be negative 4x. And then you are supposed to bring down 5.
Don't you hate when your hand gets sweaty while you're writing and then like the pencil slips?
That doesn't happen.
You have to write extra hard. Well, what's
What
happening?
remainder of 13?
Nerdy.
What happened when I kept going?
So then, what do you multiply x by to get negative 4x?
Negative 4.
So at this point, if you'd like, you can stop. Okay, you can keep going just to make sure that you don't get a remainder of 0, but you don't have to. Because the remainder doesn't matter. Our slant asymptote is going to be at y equals x minus 4, whether we keep going or not.
Ugh.
As long as you
Yes,
get it right.
that's what I got.
Oh, very.
He's a little gross looking.